Trigonometry or trigonometry. Trigonometry is the branch of math that deals with the relation between the sides and the angles of the triangles and how to calculate them, how to solve the triangle, particularly is the trigonometric functions. We are going to study in trigonometry how to find the ratio between the opposite side and the hypotenuse adjacent, how to solve the triangle, how to find the missing angle and the missing length of sides. Before we start in trigonometry and understand how to find the ratios, we need to define the opposite side and the adjacent side for the angle inside the right angle triangle. If I have angle here which is called theta, this side opposite to the angle 90, and this is called always the hypotenuse side, and it's the longest side in the right angle triangle. So always the longest is the hypotenuse. The side at the front of theta, we called it opposite. So the side adjacent to it, we called it adjacent. Notice that if we draw the same triangle, hypotenuse will not change its place. But if we change the place of theta, this side will be opposite and that side will be adjacent in this case. The ratio between the opposite side and the hypotenuse called it sine. And we are taking the first three letters of S and O and H, and we have so. Then the cosine is the ratio between the length of the adjacent side and the hypotenuse. And the same for tan, it's the opposite over the adjacent without the hypotenuse length. So if we put these each three letters together, we have the word SOHCAHTOA. SOHCAHTOA for sine, cosine, and tan. Sine is the ratio between the opposite and the hypotenuse, cosine adjacent and the hypotenuse, and the tan opposite over adjacent. For example, if I have a right angle triangle, a well-known right angle triangle, you know it, 3, 4, so the length of the hypotenuse is 5, and this A, B, and C. And I wanted to find the value of sine A. Sine for SOHCAHTOA. So sine is the opposite of the angle A, which is equal to 3, and the hypotenuse, which is equal to 5. Notice that if I am looking for cosine C, opposite of the angle C is 4, and the hypotenuse is 5. For the cosine of the angle A, adjacent over hypotenuse. For the tan of angle A, it's opposite over adjacent, 3 over 4. For the cosine of the angle C, the adjacent in this case is 3, and the hypotenuse is 5. And for tan of angle C, it's 4 over 3. What do you notice about the angle A and C? We notice that they have the same value but opposite trigonometric functions. So sine A is the same as cosine C, and we called it cofunction. What if I wanted to solve this right angle triangle? And the meaning of solve here is to find the missing sides and the missing angles. It's clear for us that the measure of angle B is equal 90 minus 35, which is equal to 55 degrees. But how I can figure out the length of A without using Pythagorean theorem? I can figure out the length of A without using the Pythagorean theorem by applying the tan rule. Tan of the angle A, which is tan of 35, is equal to the ratio between the opposite A and the adjacent 8. So how I can find A? It's 8 multiplied by tan of 35. What if I wanted to find the value of C? I can use sine the 35, sine this angle. Opposite, which is A, over hypotenuse. It's equal A over C, and I already figured out the value of A. One of the students may ask me, Mr. Sham, can I use the cosine? For the example, cosine of A is equal 8 over C, and A is equal to 35. Yes, and directly you can say that C is equal 8 over cosine of 35. Cofunctions is a trigonometric functions that it's a trigonometric function for the complement angles. And what do I mean by complement angles? I mean that, for example, if I have a triangle, right, and you have angle here A and B, angle A and angle B, their sum is equal to 90. So we call them complement angles. We call them complement angles. What is the relation between the cofunctions of the complement angles? That the sine of one of them is equal cosine of the other, and the tan of one of them is equal cotan of the other. What is cotan? What is cosec and sec? It's the reciprocal values of the sine and the cosine and the tan. All what you need to know that sine is the reciprocal of the cosine and the cosine is the reciprocal of sine. For example, if I wanted to find the value of the angle theta, and sine 13 is equal cosine theta. The only case for sine to be equal to cosine that 13 and theta, their sum is equal to 90 degrees. So measure of angle theta here is 77. Another example. Sine of theta is equal to 65. So for sure, sine is equal to cosine. So 65 plus theta is equal to 90. So the measure of angle theta is 25. Notice that the value of tan of any angle is equal to the ratio between sine of the angle and the cosine of the angle. For example, if you have a right angle triangle here, and this angle is theta, but you know what is the value of the sine and what is the value of the cosine, you don't need to draw the right angle triangle or to figure out what is the answer. For example, if sine theta is equal to half and cosine theta is equal to root 3 over 2, so the value of tan theta is equal sine theta over cosine theta. So it's equal 1 over 2 divided by root 3 over 2, which is equal 1 over root 3. Something else, you may write the value of tan theta as cosine 90 minus theta over sine 90 minus theta, the cofunction of the angle. As we know that cosine 90 minus theta the same as sine theta, and sine 90 minus theta is the same as cosine theta. Radian and degree of 2 units angle. We have 2 units for measuring any angle. We have a degree measure out of 360, and we have a radian measure out of 2 pi, which represents the length of the circle. But notice that while you are working with the angles, pi here is equivalent to 180 degrees, not equivalent to 3.14. Again, pi here is equivalent to 180 degrees since you are working with the angle. To change from degree to rad, you are multiplying by 180 over pi. But for change from degree rad to degree, you are multiplying by pi over 180. For example, what is the angle 225 degrees? As we can see, here is the degrees into radian. So you wanted to find the value of the radian. So you are going to multiply pi over 180 multiplied by the angle. And there is another method by dividing 225 by 180 and you just add pi. Of course, after simplify, which gives you 5 over 4 pi. What about changing from radian 2.37 to degrees? So you are going to multiply 36 by 180 and divide the answer by pi, which gives you 135 degrees. If you have arc length, but the measure of the angle in radian, not in degree, and you wanted to find the length of the arc S here, so S represents the length of the arc, you can simply multiply theta, but theta should be in radian measure, multiply by the radius length. So when I'm using this rule, theta rad multiplied by r, only if I have the given of the angle as theta in rad. For example, if I have inscribed central angle 3 pi over 5, and I have arc length 3, what is the length of the arc? So it's going to be theta rad multiplied by r, 3 pi over 5 multiplied by 3, which is 9 pi over 5. Mr. Hisham, do I have to change pi here into degrees? No, pi here is in length, because this is length, inches, which is approximately 3.14. So we keep it like this in terms of pi. But notice the difference between pi in length and pi in measure.